CPs, GPS, RTK, and PPK. Those are the things we're going to be discussing in this short series. Why do we need them? What are they? How do they work? First, we're going to go to Australia and speak with Rory and Miguel from Propeller AeroPoints. We're going to talk to Rory about his journey in this drone mapping business, how he got started, why they created Aero Points. Rory has given us a very candid interview, and this interview is about 30 minutes long, but in the description below, I've put time stamps with sections of topics that we covered in this interview. So if you want to watch specific things, you can look in the links below and go to that section. Now, I highly encourage you to watch the complete interview because it's full of information that I found very useful, and I think you will too. And also, Roy has agreed that if anyone has any questions or comments, leave them below and he will respond to those. All right, after that, we're going to go to St. Petersburg, Russia, and we're going to talk with Dmitry from MLID about Reach RS and their product. And then finally, we'll end in San Antonio, Texas, where we met with Brian from Toughwing. We're going to show the product that he's created and how he's done it. And I think between all of these people, everyone's going to find that the information they share is not just how to become more accurate, but it's also how they found their niche in this newly emerging market. So I'm hoping that you're going to get as much out of this as I did. All right, let's get started.
Okay, well, so let me give you a background. We started off in 2014 in Australia wanting to help. We actually decided to build like a drone that would capture the same data every day for quarry customers. And we went to them and we said, hey, buy our drone. And they came back and said, look, we don't want your drone. We use drones, we like them. What we really want is to make the data easy for us to get into our CAD systems, like make us the API for drone data. So that's a much better idea. So we put away the drones and just went full-time on software pretty much from the start of the business. And the very first job we actually delivered we went to a local quarry, said, hey, look, let us fly these surveys. It'll cost you half the price what you're paying now. We called the local service provider to do the actual flying. We captured the data. The quarry said that they had ground controls already on site. But of course, you get to the sites and they're washed up and they're kind of, they're broken and the coordinates are scribbled on a piece of paper, and so you think, wow, this is not going to work. But we only found that out once we had those images, so it was almost too late. Now, the quarry didn't like that. They were frustrated. We were frustrated. So we thought there needs to be a better way to guarantee accuracy regardless of the drone, and especially for non-surveyors, because obviously all of these drone service providers increasingly were not surveyors. We launched them about a year ago on the market, and they've been wildly successful, to be honest. We've got them in, must be 50 or 60 countries now. What we really care about at Propeller, I suppose, our mission is to make this data as accurate and as useful as possible, and really trying to give work sites the ability to sort of analyze all of this information themselves. So every time a set of Aero Points is used, we hope that means more accurate data has been created en masse. We really need to be putting our best foot forward as an industry. And that's why we think that there's almost no excuse now for not collecting accurate maps.
Right. Yeah, that's interesting. Is it an RTK? Is it something kind of different that's similar? How does that work?
Sure. So they're a PPK unit. So they sit there and record their own raw GPS data, essentially. They upload that information automatically to our cloud. And then there's a few different ways you can process. So the first and the most common is just against our Propeller sort of managed cores network. So we manage a bunch of core stations, both publicly available, private. We sort of manage all those subscriptions and allow our customers to process against those stations. So that's the first way. The second way is you can put the Aero Points down on a known point, like a known survey benchmark.
Sure.
And then you can actually key in the coordinates of that Aero Point that you've put down on the benchmark and all of the other Aero Points reference against that one Aero Point. You get very accurate data.
Okay.
And you can apply the same. So that obviously works when you're outside of coverage on the core stations, and it means that each Aero Point is essentially its own rover and its own base. So we end up correcting each Aero Point against each other Aero Point and doing a big network adjustment to go and tie down those accuracies even further. And in the case that you're putting one of the Aero Points down on a known benchmark, then you end up with a very short baseline measurement resulting in very high accuracy data. Does that make sense?
Oh, yeah, yeah. And
I've actually got one here for you.
Oh, perfect. Yeah, I'm glad I did that. I was going to ask you, how much does one weigh? It looks pretty light.
Probably 1.5 pounds.
Yeah, okay. Yeah.
Less than a kilo?
Good. Yeah. I had heard that they were heavy, and then I saw a video, and I thought, man, they do not look heavy. So that's good confirmation anyway.
So the weight, like there's a bunch of interesting things that have gone into the manufacturing here. So to be honest, we didn't want them too light because then they blow away in the wind. So
sure.
So the weight of the Aero Points is actually just enough, and the beveled edges, as you can see,
right,
just enough so that they can handle winds that like a Phantom 4 Pro can handle. And we've got a bit of a sort of rule of thumb: if the Aero Points are at risk of getting blown away, don't fly your drone.
Right.
It's too windy.
Yeah. So that's good.
So obviously, we can't make them too light because they then become, blow away in the breeze.
Right.
A few other things, just quickly on the design as well. Like you'll notice that it's grey and black rather than white and black. Can you guess why?
White being too reflective?
Yeah, exactly. So it blows out in the sun, and this is a special 17% grade grey. You put 17% under the sun, take a photo of it, and it looks like white, but you don't get any of the flaring on the lenses. So you'll still get that point really clearly. And actually, look, in the sun, look at this. There's a lot of sun here where I am right now. If I move my camera.
Oh, yeah.
Can you see how white that is?
Yeah. When you have it just the right angle, you can tell.
You get that, and you don't get any reflection. So that's super important.
Yeah. That's interesting because one of the things that I've had to do when using a Phantom is I would take my propellers and I would dye them either a gray or a black. That reflection hits that camera and causes the lines. And
totally.
I don't know why they ever put white propellers on those things, but
it flares out. Yeah. So that's really important. A few other things to note about them: they are only waterproof and sealed. So there's actually only this one button here. If I press that, it'll light up, as you can see.
Oh, yeah.
Now that's recording. If I press that again, now it'll go into an uploading mode, and it's going to upload its data and turn itself off. That's it.
Oh,
there's only one button operation. So not only can you not screw it up, but it's almost tamper-proof. You can't interfere with the coordinates that are generated. And so for a lot of the technical applications where you need almost validated data, an Aero Points CSV file, it's impossible for a customer to affect the coordinates of that. So if you're on a landfill or a quarry and they've got compliance, they're only allowed to fill up to a certain height. Putting the Aero Points down and getting actual points off them, it's the customer can't sit there and sort of minus or plus feet to adjust to make it more sort of favorable for the site. So quite important.
Yeah.
Now the other thing is a special matte finish solar panel.
I was going to ask about that.
If you can see it.
Yeah.
Yeah. So these never run out of battery. They totally self-sustaining. You can leave them in there's a really big battery under here, big enough that it will last weeks sort of out of the sun, but it's only a few hours in the sun with a big panel to get it back up to full. And I suppose by default, you're using these during the day when you can see them when you're mapping, and so they're almost always charging.
Nice.
So
Okay.
as a result, there's not even a charging. You can't even plug it in. There's absolutely no opening into the unit.
Right. Okay.
Well, I was just going to say, like as before, very important to make this panel non-reflective, and most solar panels are reflective nature. So there was a bunch of challenges, obviously, in getting these manufactured properly, where we needed to make sure that they'd perform in all lighting conditions and with all cameras and with all drones.
Right.
And so, we picked the worst possible setup, like a 12 megapixel wide angle GoPro at 120 meters or 400 feet, and said, we've got to be able to see them, and worked backwards from there.
Oh, nice. Okay. I think the 12 megapixel camera was a good place to start, but it's really not the best way to map.
No.
So
we're very glad that the Phantom 4 Pro is sort of doing a lot of heavy lifting now. It's a great unit. It's a beautiful camera.
Yeah, that mechanical shutter, everything.
It's just lovely, isn't it? It's a really important note, and it's worth saying that some people come to us and they say, hey, can you add QR codes to the Aero Points? Can you add colors, blah, 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 to make them more uniquely identifiable? And we actually experimented with so many different surface patterns to try and add more information to the surface, so we could differentiate between units in a set really easily. And after all of the different permutations, we actually settled back on just such a simple checkerboard because we wanted to guarantee that it would work reliably under all conditions, in all lighting, with all cameras, and we couldn't guarantee the best or the worst quality cameras out there. So that became this is how we ended up back at such a simple solution. But I think it has a bunch of other benefits as well. So now every user has 10 of the same thing, every customer, rather than each unit is a slightly different pattern, and if they need a replacement, then they've got to get a replacement. You can just imagine how frustrating that would become. And they can mix and match sets, and they can kind of combine them, and they can separate them all without any consequence, because there's no concept of a master Aero Point. Each Aero Point is entirely sort of standalone. Each has its own Wi-Fi, its own GPS. So there's no mother or father unit that sort of serves as a connectivity hub for the others.
Right. Okay. Interesting. Yeah. Sometimes the best solution is the most simple solution, right?
Simple. GCPs work. Let's put the GPS in the GCPs. Let's go.
Right. Exactly.
Because it doesn't get more simple than that. If you drag it into Pixel, you're going to have an approximate location.
Right.
And there shouldn't be any sort of confusion as to which Aero Point is. It'll be close. It'll be close, if you know what I mean.
Yeah.
And so we haven't had issues.
Okay. And I can see that, because it's pretty good about telling you which image is what point.
Totally.
So.
Exactly right. And I think, for us, for our photogrammetry process, as an Aero Points customer, you actually can upload your images into Propeller, and we take care of all of the pinning, generating all the different models and outputs, and obviously putting it into our own cloud solution, which lets you analyze the data. So if you're of the view that you don't want to be sort of doing your own photogrammetry, you don't have a fast enough computer, whatever, too busy, then you can upload those images. We do all of that pinning, run QA, sort of generate accuracy reports, and then you get an email, 12 hours later saying the data's ready.
Right. When you upload your images, do you just wait till the next day to upload them, or does the system wait for the data to catch up?
It waits. That's right.
Okay.
So the actual post-processing of that Rhinex data we've fully automated that, and it's like quite interesting and amazing, I think, actually getting that to work in every coordinate system with every datum and with a few different types of like processing methodologies. So obviously the most the method that introduces the most uncertainty into turnaround time is using the cores network that we manage, and that's just because some of the stations release their data slowly, which is frustrating. But you can upload your images and actually attach that Aero Point survey to the images, and then once that data has been processed automatically, that'll fire up all of our backend systems to then do the photogrammetry without the user needing to bother themselves.
Gotcha.
In the event that you put one of the Aero Points down on a known point, that actually covers off the that processing happens almost instantly. You'll get the results back in a few minutes, because we're using the Rhinex data from our own Aero Points to correct the other Aero Points. There's nothing outside of the Propeller ecosystem that's required aside from the accurate coordinate of one of those points.
Ah, okay.
Does that make
Well,
sense?
good. Yeah, totally. One of the reasons that I had started this channel was because I found it difficult to understand how to use drones, and I had to go through this lengthy process, and it took a while to figure out you can't just fly a drone and get accurate measurements.
No.
You need, actual hard coordinates that are going to make those adjustments. And so one of the things that I appreciate about getting the opportunity to talk with you is because I wanted to let other people know, because there's a lot of people that are excited about drone mapping, but they have no idea that you have to have
started.
And so I didn't even think of Propeller as a PPK system, but it really is the best way to go, because you don't have to worry about having that real-time connection and did it miss something, or did the connection get cut off? And so I like the idea a lot better.
To be honest, it's actually even better than that. So the little tricks that we play with the Aero Points are quite interesting. To start with, because like I said before, there's 10 units in the field all recording at the same time. They're all sitting there in the same position logging static data. We're not trying to solve for velocity. We're only trying to solve for position. So you take out a large proportion of the GPS sort of resolving equation, makes it a lot simpler and a lot more robust. So we assume that they haven't moved, and so we get much better signals. And then we do the post-processing against the cause station or against the mother aero point, and then we actually process each aero point against each other aero point. So we end up with this big sort of 10 by 10 solution matrix where you can see the errors, they stand out really clearly. So there's two big advantages already. And because, like I said, each of those aero points is on such a short baseline from each other aero point, the results are sort of millimeter grade. Like they're that good because they're so close.
Right.
Now with the Rhinex data itself, people say, what happens if the aero points get moved? Right? And this is a problem that exists for all ground control points. Well, because we're recording their position all the time, guess what? We can see when they move.
Yeah. And it'll make adjustments, right?
It's very clear. That's right. And so we can split those logs, and we've got a pre-move and a post-move. And you can, it all becomes very manageable, because you're not assuming that you're getting that sort of feed coming in throughout the length of the measurement. And then the last thing is, unlike the dual frequency sort of high-end units that need to get an instantaneous fix, really accurate instantaneous fix, because we're sitting out in the sun for 30, 45, like an hour, maybe an hour and a half, whatever it is. We have such a long measurement window that you actually see the satellites move through that period. Like all of the satellites that it's tracking, they exist, not just snapshots of those satellites, it's actually tracking them continuously. And when you do that, you can see the multipath errors really clearly, because all of the bouncing, you're not ever affected by the individual bounces. You're getting a much smoother sort of continuous stream from the satellites.
Yeah.
So we cut out multipath, and then the other thing is that they're nice and big. And like one of the obvious ways to cut multipath error out of GPS signals is to have a big ground plane. Right? You need a big sort of metal, dish beneath your unit, beneath your receiver to kind of help improve the multipath, dealing with multipath rather. And so right under here is just this big, beautiful ground plane that keeps that nice and clear. And that makes up for the fact that we're not elevated on a 2-meter pole. They're obviously sitting on the ground. So we need to work a little bit harder to make that data good. Yeah.
Well, yeah, that actually makes sense. I didn't think about that, but yeah, you get too low, which kind of brings me to one of my last questions anyways. Do y'all have masking?
Yeah, we do. We do. So the way they do it as well, which is amazing, is we iterate through all these different elevation masks. Depending on what sort of surroundings the aero points are in, we'll actually process we'll start quite narrow, give very, very narrow view of the sky, because we've got so much time of GPS satellites in this area, and then we'll open them out as we go until we have enough data to make an accurate position.
Oh,
And
okay,
and
nice.
that's all automated as well. So every time someone uploads AeroPoint data, all of those things happen in parallel to provide the most accurate results possible.
Ah, okay. So last question. When you get back to your office, you hit the button and it uploads the data through Wi-Fi. So it goes back to your cloud system. Is that right?
Yep, that's right.
And then if I need a CSV file, I can just go online or whatever and tell it that's the output file I need.
That's right.
How does that?
Do you want me to show you how that looks? I'm going to show you.
Oh, yeah, that'd be great.
Okay, so what I'm going to show you is, like I said, the new Aero Points interface here. All right, so you log on and you'll have a set of Aero Points like this. You'll have them shown horizontally when they were last connected, the battery level. You can actually see that little indicator shows the battery performance of each Aero Point. If there's any warnings, it'll give you the warnings. What are the default units for this set? So we obviously support, meters, international feet, US survey feet. You can add other people to the set of Aero Points. So we work very closely with Trimble, it turns out, and they're proud owners of a set of Aero Points here.
Good.
And we can show all of these Aero Points. This is all of the ones that they've got. So they've got 21 units. Now, each of these actual flights is an Aero Point set. So it's this one has been processed using a known Aero Point position. We can click into it. This is showing us where they actually the Aero Points were. And if we click on any one of these points, it'll take us down to all of the accuracy data for that point. So this is point 1. It was out there for 3 hours, 20 minutes. So quite a long time.
Right.
This is NAT 83 coordinates. This is its Colorado State coordinates in Northings and Eastings on the American height datum. And very importantly, this is the variance of the data that we've gotten out of the unit.
Right.
So you can see how, what that is saying is all of those 1,066 points that the unit captured during that 3 hour, 20 minute period fit inside a bounding box that is that big. That's almost outrageously tight.
Right.
And if we scroll down, you see the points will all differ slightly in their overall accuracies. And if one of them is next to a tree or a building, for example, it might be a bit lower.
Right.
So you've got all of these points here. We can also look at the timeline. So this is how the points were used in terms of like overlap from one to the other. And obviously the Aero Points get the best results when there's as much overlap as possible because they're all able to correct, properly against each other.
Right.
And your question before, what datums do we support? What coordinate systems do we support? Here is what this current project is set up in, but you can actually change this to whatever height datum you want, whatever coordinate system you want. And you can change the units obviously as well. And that'll all reproject in the browser. And then when you come up to the top here, you've just got this big download button, download a CSV, and that'll generate a CSV right there. In the browser for your usage in Pixel.ly or Agisoft. If you want to upload your images, you can just hit upload images, and that'll take you into the uploader where you can drag your images in.
Man, y'all
Makes sense?
definitely made a user interface friendly.
Yeah, exactly. And I think just to show you what it looks like if you haven't processed a set. So see this one in Broomfield, for example. Flight is ready for processing. So we can press process now. And here we have our option. So we can do it against the propeller correction network. And you'll see that it actually shows us which satellites, which cause stations are around that we can use.
Okay.
So you can see that you're in good coverage here. You can click. We can do the global survey benchmark, and we might say that this point 4 is on a benchmark. So if we click that, that's actually started. So this is going to be the base Aero Point, and now we can enter the coordinates of that Aero Point over here. We can do a local site benchmark. We can do a PPP but this is the sort of the least accurate method. And finally, if you've got your own Rhinex data, you can upload the Rhinex into this interface, and it'll process against that.
Nice. So what if you're outside of a coverage area? Can they create a localized system?
Yeah, totally.
Oh, man, there you go.
So if you're outside of coverage, you can stick it down on a global survey benchmark, like imagine this one, for example, and you can just enter the coordinates. Is it geographic projected? It's in US survey feet, measured to the top of the Aero Points or the ground. What projection are we in? Yeah, that'll do, etc.
Wow.
Enter the eastings, northings, ellipsoid height, and then you'll get all of those Aero Points corrected against that point, irrespective of the coverage network.
Right. Wow. Well, man, that's great.
Does all make sense?
Oh yeah, definitely. I think you make a good salesman.
Oh, thanks. Well,
I'm sure it helps. Okay.
Sorry, yeah.
I was gonna say, I'm sure it helps to have a passion about what you do. So.
Yeah, well, I mean, to the point you made earlier, it's just been so interesting and challenging to get all of the world's coordinate systems sort of consolidated into this product. And now that we've done it, it just feels crazy for anyone to try and figure it out on their own.
Yeah, oh yeah.
Buying the Aero Points is the easiest and the quickest way to get into high accuracy mapping that's relevant sort of to those local sites.
Yeah, so the good thing is it sounds like you don't have to be a surveyor to make accurate measurements.
No, that's exactly right. Finally.
Yeah, right.
And that's not to discredit surveyors at all. It's just to help open up the field to people that aren't as technically trained and give, hopefully, the surveyors an opportunity to do some of the other work that really does call on their experience.
Oh, yeah, sure. I have a lot of surveyors that watch the channel, and there's a lot of them who are just as interested in utilizing drone technology as there are that are totally against it.
We totally agree. To be honest, we expected the biggest type of customer of the Aero Points would be service providers, like drone service providers, and surveyors who already had the equipment wouldn't necessarily be like well-suited customers just because they've already got expensive Trimble or Topcon equipment. But as we've gone, surveyors are starting to pick them up now because they're all interested in being as efficient with their time as possible. And so the time they can save on a site is really important when they're charging, for a lot of their sort of technical abilities that often is back in the office doing design work or in any of the CAD applications.
Oh yeah.
Now it's almost 50-50 surveyors and non-surveyors, but I think all of them feeling good about the ability to get accurate data from the product.
Oh, sure, yeah. I mean, that's the name of the game, right?
For sure. And look, if your users have any, or your viewers rather have any questions, get them down into the comments, and I'll make sure to keep track of it. Great.
Okay. Thanks. Yeah, and I'll put the website in the link below or in the description.
Yeah, for sure. We've also just opened up a Denver office, so if there are any Colorado locals, they can come and see them, and that speeds up sort of the fulfillment and the shipping of the units as well. So,
thanks a lot, Rory. I appreciate your time.
Thanks very much.
All right, take care.
Thanks, mate.